geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. Three balls of masses 2 kg, 4 kg and 6 kg respectively are arranged at center of the edges of an equilateral triangle of side 2 meters. Okay, it is like this. Let us take the equilateral triangle. Let this is the equilateral triangle. The each side of triangle is of equilateral triangle is 2 meters. 2 meters. Then look at the angle. This is the 60 degrees. All angles are 60 degrees only. Okay, 60, 60, 60. Then it is given that 2 kg, 4 kg and 6 kg masses are arranged at the center of the edges. It is like this. This is the one mass. Let that is 2 kilograms. This is the another mass. The middle of that edge is 4 kg, and at the middle of the base 6 kg. These are the three masses. Okay. Then the moment of inertia of the system about an axis through the centroid and perpendicular to the plane of triangle will be. You are asked to decide moment of inertia of the system about the centroid and perpendicular to the axis of the plane of triangle. Okay. For that, what you do is from top edge you project a vertical line that is meeting the center of the base. Similarly, from this edge, draw the diagonal towards the center of the other face that is meeting that mass. Similarly, these are another 1 minute. These lines are meeting at the centroid. These lines are meeting at the centroid. Then look at the centroid. This is the centroid. Let it be C. Then, as you know, this angle, listen carefully. This angle, this angle is 60 degrees. Then this angle equal to 30 degrees. 30 degrees. Now, with that, what you do is, I am going to construct a right angle triangle like this. For all, you can construct like this. For this right angle triangle, this is the center of mass. So, this distance equal to 1 meter. This equal 30 degrees. 30 degrees. This is the x. Then what is the tan theta? Tan theta equal to x by 1. Here theta is 30 degrees. Tan 30 degrees equal to x. X equal to what? 1 by 2, 3. So you're asked to decide the moment of inertia of the system about an axis through the centroid and perpendicular to the plane of triangle. The moment of inertia about centroid. Moment of inertia about the centroid and perpendicular to the plane of triangle and perpendicular to plane of triangle. Plane of triangle. I equal to I equal to m1 x1 square plus m2 m2 x2 square plus m3 x3 square. Dear friends, remember here x1 equal to x2 equal to x3, that is equal to x, we got it is equal to 1 by root 3. But m1 equal to, let m1 equal to 2 kg, m2 equal to 4 kg and m3 equal to 6 kg. These are the three masses given: 2 kg, 4 kg and 6 kg. Let us substitute all values. m1 2 into 1 by root 3 whole square plus 4 into 1 by root 3 whole square plus 6 into 1 by root 3 whole square. Simplify it. 2 by 3 plus 4 by 3 plus 6 by 3, it is equal to 3, 12. 12 by 3, it is equal to 12 by 3 equal to 4. Moment of inertia kg meter square, because I equal to mk square na, in terms of radius of gyration, mk square. M is in kg, k radius of gyration is in meter square. So 4 kg meter square. Answer is 4. Understood clearly? Yes. Then look at the another important question. It is asking like this. Try to read it clearly. If the radius of the earth is reduced to 3/4 of its present value without change in its mass, then value of duration of the day of the earth will be dash hours 30 minutes. That means for the same mass, if the radius of the earth is decreased by 3/4 of its original radius, what is the time taking to complete the day? For the time per day? Okay, that is the question. For the radius r and mass m, the time taken per day is 24 hours. Okay, so with that, the earth is coming under a solid sphere. For a solid sphere, for a solid sphere, I equal to 2 by 5 m r square. Okay, now let us take the, or let us consider the conservation of momentum principle. By conservation, by conservation of momentum principle, momentum principle, the angular momentum before reducing the radius equal to angular momentum after reducing the radius. That is I1 omega 1 equal to I2 omega 2. Here I1 equal to 2 by 5 m r square, I2 equal to 2 by 5, mass remains same, but r is reduced to 3/4 of its present value. 3/4, not 3/4. Should be very careful. 3/4, 3 by 4 times the radius square. Simplify this value. I2 equal to 2 by 5 into m r square into 9 by 16. 9 by 16. Omega equal to 2 pi by t, where t is the time period. Then I1 equal to what? 2 by 5 m r square into 2 pi by t1. This t1 is 24 hours with original radius. I2 equal to 2 by 5 m r square into 9 by 16 into omega 2 equal to 2 pi by T2. Let us cancel 2 by 5 mr square, 2 by 5 mr square, 2 pi. Then finally it is 1 by T1 is equal to 1 by T1 equal to 9 by 16 into 1 by T2. Okay, 1 by T2. Let us take another slide. 1 by T1 equal to 9 by 16 into 1 by T2. From this T2 equal to 9 by 16 into T1. You know, time period per day equal 24 hours. 24 hours. So it is equal to 9 by 16 into 24. Here it is uh, 4, so 8 2 jar, 8 3 jar. It is 27 by 2 equal to 13.5. 13.5 hours. Therefore, to complete the day, time required when radius is reduced to 3/4 of the radius of the earth is reduced to 3/4 of its original value is 13 hours. 0.5 hours means 30 minutes. So only 13 hours, 30 minutes are sufficient for completing the day. So 13 hours, 30 minutes. Look at the options. Dash hours means 13 hours, 30 minutes. Got that point? It is also very important problem. I can say 5-star problem, most expected problem. Okay, na? Similarly, let us take the another important problem. Look at the problem. It is asking like this. A hollow sphere is rolling on a plane surface about its axis of symmetry. A hollow sphere. Previous problem is for solid sphere because the earth is treated as a solid sphere. But this problem is for hollow sphere is rolling on a plane of surface about its axis of symmetry. The ratio of rotational kinetic energy to its total kinetic energy is x by 5. Then what is the value of x? Okay. For a for a hollow sphere, I equal to 2 by 3 mr square. Okay. Then rotational kinetic energy, rotational rotational is asking the ratio between the rotational kinetic energy and the total kinetic energy. Rotational kinetic energy equal to half I omega square. Half I omega square. Next, here total kinetic energy means sum of the rotational kinetic energy and linear kinetic energy. For that, linear kinetic energy equal half m v square, but linear velocity v equal to omega into r. It is equal to half into m into v omega square r square. Omega square r square. Of course, in the place of I can write 2 by 3, 1 by 2 into, right, I value 2 by 3 m r square into omega square. These two cancelled. So finally it is m r square omega square by 3. 3. So that is the for rotational kinetic energy. Then the ratio between rotational kinetic energy divided by total kinetic energy is nothing but rotational kinetic energy divided by rotational kinetic energy plus linear kinetic energy. So rotational kinetic energy. What is the rotational kinetic energy? Mr square omega square by 3 mr square omega square by 3 divided by mr square omega square by 3 plus linear kinetic energy mr square omega square by 2 mr square omega square by 2. This mr square omega square getting cancelled. Finally it is 1 by 3 whole thing by 1 by 3 plus 1 by 2. It is equal to 1 by 3 divided by 6. 6 here it is 2 plus 3. It is equal to 1 by 3 into 6 by 5. 3 2 times. It is 2 by 5. The ratio between the rotational kinetic energy and total kinetic energy is 2 by 5. But what it is given? X by 5. Here x equal to. It is equal to x by 5. Then what is the x value? X value is 2. Answer is. Got that point? Yes.
Geobyte.